My name is Thales. I am a software engineer here at CodePlace Software. From CodePlace perspective, our goal was to build an OpenCL profiler that could be used to profile any application running on any device supporting OpenCL, like this HiKey 960 board here. In this video, I'm going to show how can you profile your application in a wide range of devices that supports OpenCL. On top of OpenCL, we also built a profiler for Compute CPP, which is CodePlace implementation for the SYCL standard. The profiler we've built is based on a tool called CodeXL. We've modified and extended this tool to enable profiling different OpenCL devices as well as Compute CPP. In this video, we are going through the process of creating a new project inside CodeXL and how can you inspect the profiling data captured using our tool. Okay, so now I'm going to show you how to create a project inside CodeXL and how to profile your application. I'm going to use one of our samples that are available on GitHub from our Compute CPP SDK. So the first thing you need to make sure of is that your application is running. So I'm going to show you this now. So in this folder here, I have the Compute CPP SDK built with all the binaries. So I'm going to execute one of them here called reduction. So as you can see, when I run this executable, it runs it using the SYCL runtime and also using the regular STL library for doing the reduction operation. So now I'm going to open CodeXL to create a project and profile this application. So here I'm going to launch CodeXL. So when CodeXL opens, you can come here to File, New Project. Here, the first thing you want to do is select the executable path by clicking on this button here, and you can navigate to your executable. So I'm going to select here the reduction example. In this screen, you can set all sorts of options like command line arguments and environment variables. For this particular example, we don't need to change anything else. I'm going to give another name to this project. I'm going to call it SYCL reduction. After that, you need to set that we are using the SYCL runtime. So for this, you can click here on Application Timeline Trace, and here you can select the runtime you want to profile. For this project, I want to use the SYCL runtime. In SYCL, you need to tell CodeXL where the SYCL runtime is located. You can do this by clicking on this button here. And here, already on the correct folder, I just need to select the libcomputecpp.so file. Click Open, and that's the only thing you need to set for profiling SYCL applications. Click OK, and CodeXL is going to create your project. CodeXL works in different modes. For the SYCL profiler, you want to change to the profiling mode. So here in the profile menu, you can click here on Switch to Profile Mode. After in the Profile Mode, you come again here in the Profile menu and you select Application Timeline Trace. This is the mode that we've modified to enable CodeXL to profile SYCL applications. In order to start profiling, you just click here on GPU Profile. In this particular example, this is output from the application where you can attach a debugger if you want to. In this case, I just want to execute. After the execution finished, CodeXL is going to display you with the timeline trace of your application. So as you can see, there are OpenCL events, there are SYCL events, and you can see what the device is doing and what the SYCL scheduler is doing for you. So you can zoom in into the timeline and you can see exactly how much time your kernel took to execute. In this section of the video, I'm going to show how to profile a TensorFlow example application. The examples I'm using can be found in this GitHub repository, and you can also find this link in the video description. For this video, I'm going to use the basic operations.py because it is a short example and we can show our profiler working with TensorFlow in this video. So I'm just going to run this example here, and we can see what the results are for this particular example. Okay, so now we can see that this example is working, and it is also using our OpenCL device, and it's also using our SYCL device in this machine. In order to profile this application, we are going to create a CodeXL project now. First, I'm going to launch CodeXL. After that, create a new project, going to File, New Project. For TensorFlow applications using the Python API, the executable path needs to be the Python executable. In the case of this machine, this executable is located in /user/bin/python. The working directory should be the folder where the example is located. In this case, it is this folder here. I'm just going to copy and paste this folder here in the working directory. The command line argument should be the name of the script we want to execute. In this case, it is called basicoperations.py. I'm going to copy the name of the file and I'm going to paste here in the command line argument section. I'm going to give a name to this project. I'm going to call the TensorFlow example profiler. Now we need to enable the SYCL profiler for this project. To enable the SYCL profiler, go to Application Timeline Trace, select SYCL, and click on this button here to point CodeXL to where the SYCL runtime is located. I'm already in the correct folder, so I'm just going to select the libcomputesbp.so file. After that, just click OK, and CodeXL will create your project. Before start profiling, we need to switch to Application Timeline Trace profiling mode. To do this, go to the Profile menu, click here on Switch to Profile mode, and click on the Profile menu again, and then select Application Timeline Trace. After this, just click on GPU Profile and wait for the application to finish. When the application finishes, CodeXL will display the profiling data for you. You can inspect the data and see how SYCL on top of OpenCL to execute TensorFlow on an OpenCL capable device. As you can see, we can zoom in and see how much time the actual kernel is taking, and you can also see the SYCL scheduler working to enable these operations to be executed on the device. In order to show a more complex TensorFlow application, I'm going to show the profiling result of this example here, the kmeans.py. After executing the script, this is the result of the profiling. As you can see, there are a lot more calls to OpenCL and a lot more calls to kernel executions. We are going to keep improving this profiler in order to enable us to understand more how neural networks applications runs on particular devices. Thanks for watching our video, where I explained how we develop an OpenCL and SYCL profiler for developers by adapting the CodeXL project. We are continuing to implement enhancements to CodeXL and making new releases available. We are also working towards integrating our code into the main CodeXL project. If you want to download our version of CodeXL and look at the source code, visit our GitHub project page. If you want to download ComputesBP, CodePlay's implementation of the SYCL standard for heterogeneous programming, visit our developer website. These links are also available in the video description.